Okay, continuing on with 2.1, more factoring. Okay, so the directions here are actually just saying factor. Factor each expression. Secant squared of theta minus 1. Think about how you factor. Remember our old factoring rules. We start with the GCF. Clearly, there's not a GCF between our two terms here. The next thing you look at is the number of terms. If you've had me before, you should remember this flow chart we talked about. First thing, GCF, then how many terms? In this case, there's 2. If there are 2 terms, we look for a difference of squares. Certainly, this is a difference of squares. This is clearly something squared. This is clearly a difference. And 1 is something squared. It's 1 squared. Okay, so that is factorable. Well, the way you factor a difference of squares, it's 2 binomials. What do you square to get secant squared? You square secant. That goes first in each one. One has a plus, one has a minus. And what do you square to get 1? You square 1. Done. Can't factor any further. That is your answer. Okay, so you almost have to think of these as just regular polynomials. This has the polynomial form x squared minus y squared, which is a difference of squares. Okay, another one. 4 times tangent squared of theta plus tangent of theta minus 3. Start with the GCF. Do we have one in our 3 terms? No. Don't say tangent because this does not have tangent back here. Then, how many terms are there? Well, in this case, there's 3. If there's 3, you should be looking at AC method. If you have not had me last year, you may not call it AC method. I don't know what you guys called it, but and also I don't know if you guys do guess and check or if you do the AC method. Let me go back to a simpler problem, which hopefully you guys talked about this yesterday. So say this was the problem 4x squared plus 1x minus 3. You know it's going to break into 2 sets of parentheses, and x here, and then you figure out your signs. This would be 1 plus 1 minus, and then you have to figure out what numbers go in here. What multiplies to what adds to what, etc. So if you did not have me last year, I don't know how you did that. I don't know if you guys preferred guess and check or if you went through like what we call AC method. So let me show that to you if you guys didn't talk about this yesterday, which I hope you did. In this problem, I would say A is 4, B is 1, C is 3, negative 3. So my first step is to say, what is AC? Well, AC is negative 12. Let me just mark this off to the side. So I need to figure out 2 numbers that multiply to negative 12, but that will add to our B, which is 1. What 2 numbers multiply to negative 12 and add to 1? Positive 4 and negative 3. 4 times negative 3 is negative 12, but 4 plus negative 3 is 1. So then what I do is I replace my middle term, 1x, with these 2 numbers, and I just stick an x with them. So 4x, negative 3x. So I rewrote the problem, I just substituted in. 4x minus 3x is 1x. So my problem didn't change, it's still the same value, it just now has 4 terms instead of 3. Well, a problem with 4 terms I can factor by grouping. So in the first half, my GCF is 4x. That leaves me with x plus 1. In the back half, my GCF is negative 3. That leaves me with x plus 1. And then I can factor out x plus 1 to the front, and 4x minus 3 is left. So this is where I was saying maybe you just guess and check this. I don't know. I've seen that my students prefer, at least most of them, the majority prefer this because you always come out with the answer. It's not sitting there and guessing and checking. The more you do of these, sometimes guess and check is faster because you can kind of see ahead and know what it's going to be. However you prefer, you need to be able to factor this into this. And again, hopefully you guys talked about this on, I keep saying yesterday, but I mean on Monday. Okay, now why did I pick this problem? Well, this is in the exact same form. It's just instead of x's, I have tangent of theta. 4x squared plus x minus 3. Can you see that those are of the same form? Okay, so the factoring is going to be really, really similar. It's this same thing, except for instead of x's, I'm going to have tangents. Okay, so if you prefer, put it into just normal polynomial form, factor it, and then go back and stick those tangents, the trig functions, back in. So this factored into tangent of theta plus 1 times 4 tangent of theta minus 3. So I'm simply substituting x and tangent of theta. And that's it. It is done. Okay. Let me have you guys practice just one of these. 2 cosecant squared of theta minus 7 cosecant of theta plus 6. Pause the video and you guys factor this one. Okay, the green is my answer. Check it out. I rewrote it with x's instead of cosecant of thetas. And then in my answer, I just stuck the cosecant back in. Make sure you do not give me this as your final answer. That is not right. You have to make sure you go and put those trig ratios back in. In some cases, factoring or simplifying even can best be done by first rewriting the expression in terms of just one trig function or in terms of sine and cosine only. So for a problem such as cosecant squared of x minus cotangent of x minus 3. So we have two different trig functions here, and they're saying sometimes it's going to be more helpful if you write it in terms of just one trig function or if you just use sine and cosine. So which of those is going to be more helpful here? Well, I don't know. You kind of got to take a shot and see what happens. I'm going to go with the first suggestion, just one trig function. So how can I write these in the same form? Well, you got to remember your identities. As soon as you see one of these squared terms, you've got to look at your Pythagorean identities. And I know that cosecant squared of x equals 1 plus cotangent squared of x. Okay, so I'm going to substitute. This becomes 1 plus cotangent squared of x, and that is really helpful because now I only have one trig function going on here. I can simplify by combining 1 minus 3, so I have cotangent squared of x minus cotangent of x minus 2, and then I can factor. So again, you could do AC method here, but because a is 1, you get to take the shortcut. So what multiplies the negative 2 and adds to negative 1? Negative 2 and positive 1, right? Those are your numbers in the back, and instead of just having an x here, you have to have a cotangent of x. Cotangent of x. Again, though, if you wanted to rewrite this as x squared minus x minus 2, and that's simply by letting cotangent of x equal x, and really you shouldn't use x, you should use some other variable, maybe like y, since we already used x. And then factoring this, so what multiplies the negative 2 adds to negative 1, and we would have got y minus 2y plus 1, and then going back here and substituting the cotangent back in. Okay, let's try another one. Sine of t plus cosine of t, nope, I'm sorry, cosine of t times cotangent of t. This time our directions say to simplify. Okay, we've got a lot of different trig ratios happening. Remember our suggestion back here. If you're factoring or simplifying, sometimes the most helpful thing is to write them in terms of just one trig function or try to get them down into sine and cosine. The one thing about trig that I remember not liking in high school is that there's not always like one set path. So like when I'm solving an equation, I know my set path. I know when I multiply, when I add, when I use inverse. I know what I'm doing step by step by step. But in trig, it gets a little more messy, and it's almost more like a tree branch, and there's different options that will still get you to the final leaf at the end of the branch, but it might be a different leaf, or it might just be a different route. Hopefully you guys aren't looking like I'm thinking I'm crazy right now. But my point is it's not always a linear method to getting there. And you kind of find that as you get into higher mathematics, like when you start doing paragraph proofs. There's more than one way to get to the right answer. There's more than one route to get there. And sometimes you go down a route and you find out it's a dead end and you have to back up until you find a new route to take. So don't get discouraged. Just try something different. Okay, so we're not going to be able to make these all the same because certainly I can't make, I shouldn't say it that way. It's not going to be as easy to make them all one as it was, one trig function as it was in the last problem. So instead, let's just try to get them into sines and cosines. So this is already a sine. This is already a cosine, but cotangent, we can go ahead and change that. It is cosine over sine. Well, that's helpful right away because what happens is you have a squared term then. So sine of t plus, multiply those together, cosine squared of t over sine of t. And then remember on Monday how I had you guys working with getting things added together? Let's try that here. So we would need a common denominator, which is clearly sine of t. So multiply this one by sine of t over sine of t. And we get sine squared of t. Cosine squared is already good. It already had that denominator. Well, sine squared plus cosine squared we know is a 1. 1 over the sine of t is the same thing as cosecant of t. Now, I made this look, hopefully, pretty easy. Got you right to the answer. I didn't take any side paths, side routes. That's probably not going to happen when you're working on these problems. And if I were here with you in person, I would wait on each step and go with your suggestions. And I'm sure you would have suggestions that would not get you straight down to this answer as quickly. And what I would have liked to do is go down some of the paths you're getting. Because sometimes we might go down a path, circle around, do something else, and then get there. Okay? It's also possible that you would start doing something and find out that's not getting me anywhere, and then you'd have to go back and try something different. Okay, that's going to happen when you're doing these problems. So please don't get frustrated if you start going down a path and don't immediately get to the end. There's not one set of steps that I can just give you that will get you there every time. You might have to follow some paths that aren't going to take you there right away, but eventually you'll get there if you are persistent and you keep at it. All right, and the best way to get good at these is to just keep doing them. Okay, so there's your assignment. Practice these. Good luck, and we'll keep chugging along here.